All right, so we'd like to solve 57 out of 11.6, which is some kind of little thing with logs, right? Okay, so what does my instinct say?
Multiply.
Oh, you guys are good.
Lose the logs.
Yeah, so I'd like to lose the logs, right? But I can't put this stuff in the exponent of an e right now. It'll be kind of a disaster. But close.
It's multiply.
Yeah, this is, I hope you guys are seeing on the left-hand side, this is a multiply log rule, right? Yeah?
Yeah.
Okay, so I want to use the multiplication log rule on this left-hand side. And I'll get what out of it?
Square.
Okay, so I'll get the log of the whole thing,
Oh, okay.
v minus 4 times v minus 3. Nice, guys. And that's going to equal,
5 minus ln.
do I need the ln on the other side still?
Yeah.
Yeah, I haven't done anything to it, right? I, in fact, didn't even say I was going to do anything to the right-hand side. All I did was a log rule to the left. So the right-hand side should just be, yeah, exactly the same. A log of 5 minus b. Okay, now I want to rid myself of these logs, right? So how do I get rid of the ln's?
10.
Yeah, I put everything in the exponent of an e, right? Really, that's apply the e to this stuff function to both sides, right?
Why didn't you use 10?
Why didn't I use 10? Yeah, because it's not a log, it's an ln, right? So the base is e.
Okay.
Okay, so I got what?
E to the b minus 4.
Okay, so the e and the log are going to undo each other on the left, right? So I'm going to be left with a b minus 4 times
B minus 3.
b minus 3. And on the right, I'm going to be left with a 5 minus b. You guys see that? Okay, now what? Okay, so we want to FOIL the left-hand side. What's your motivation for doing that?
Trying to get.
Yeah, I want to get to some place where I can apply the quadratic formula. You guys see that? That's my only tool for solving things like this. Okay, so I've got v squared minus
3b
minus 3b
minus 4b
minus 4b
plus 12.
plus 12 is 5 minus v. Okay, so then what?
Plus 5.
Okay, combine like terms. So I've got b squared minus
7. No.
how much is 3 and 4? It's 7. So I've got minus 7v. Oh, and some of you are pulling that v over. You guys see that? Okay, I'm going to do it in one step or in 2 steps. You guys can do it in 1 if you're going to get it right. But get the signs right. So I've got minus 7v plus 12 is 5 minus v. Okay, now I add v to both sides. So I've got v squared minus 6v plus 12 is 5. And then I subtract 5. So I've got v squared minus 6v plus 7 is 0. Okay, now I could
Try it.
have 3 options, right? What are the 3 options for things like this? Okay, I could factor this, or I could quadratic formula, or I could complete the square. Is this a good candidate for complete the square? You guys remember how that thing works?
Yeah.
Yeah, I gotta take the b term and divide by 2. So this is a pretty good candidate for complete the square. I'm going to spend a second trying to factor, and then if it doesn't work, I'm going to cram in the quadratic formula, right? That's our usual. Just complete the square is easy to screw up, for me at least. So what do I try? I need two numbers that
7 and 1. No.
multiply to 7 and add to negative 6.
No. You can't do that.
Yeah, so I'd like to say it's right, v with a 7 and v with a 1. I need negative 6, right? Oh, so I should do this. But that multiplies to be negative 7, not positive 7. You guys see that? Whoops.
Would it be 7 minus 1?
Wait, v wouldn't be.
Yeah, once you've spent this much time on it, if it didn't work right away, pitch it in the quadratic formula.
It's not
Right.
7 minus 1.
Oh, plus 7 minus 1?
Yeah. That doesn't work.
Because it doesn't add to negative 6.
7 minus 1. And then it was like, oh, it does.
7 minus 1 adds to 6,
Oh.
not negative 6. Okay, so once I've established that factoring this is not convenient or easy, which is really all I want you to try, right? A minute, minute and a half tops factoring, right? Okay, so I'm going to pitch this in the quadratic formula with A is, B is, and C is. What are they? 1, negative 6, and 7. Okay, so you'll write down the quadratic formula. Is this a great opportunity for a quiz or what?
Yay.
Okay, quiz. Do the quadratic formula on this. Okay, so what did you guys get when you did the quadratic formula to this? You got plugging in. I'm hoping for a 6 plus or minus
Negative 6 squared.
36 minus 28 all over 2. So x is 6 plus or minus the square root of 8 over 2. So x is 6 plus or minus
2 root
2 root 2's over 2. So x is 3 plus or minus root 2. We need to factor a 2 out of the top before we can cancel, right? Otherwise we did a false cancel. Yeah, if we do just the 6 and the 2, that's a false cancel because these two things are added together, right?
Okay. So how do you make that right?
So I've got to think, okay, this is twice 3 plus or minus the square root of 2 over 2, and now I can cancel. Now this is a 1c because it's multiplied by everything, right? It's a factor, not a term. You guys cool with that?
So that's the time, at the end is when you do your division by 2,
Yeah.
the very end.
Yeah.
Okay.
But you only do it on the left side, right? Now, oh, you did it on both.
Yeah,
the
otherwise
six
it's a
and
false cancel. Yeah.
Okay.
So it's got to come out of both terms on the top because they're terms, right? So I need to factor that 2 out.
So the plus minus separates the terms.
Yeah. Plus minus really means add or subtract, right? In both cases, they're terms,
Okay,
right?
I was seeing it all.
You can certainly write this as this makes 2 answers, right? Either x is 6 plus 2 root 2 over 2, or x is 6 minus 2 root 2 over 2. In both cases, they're terms, and I'd have to factor the 2 out to cancel it. You'll get the same cancel that you would get if you did this. That's cool? All right, so my answers are x is
Oh,
Positive.
3 plus square root of 2 and minus.
good. So x is, or v. Whoops. You guys see that? Whoops. Whole thing should be v's, right? So v is, oops, sheet, handwriting today. So v is either 3 plus root 2 or 3 minus root 2. And I really should go back and make sure these don't cause problems. Let's see, so, what do I need to check for these?
That they're not negative or 0.
Yeah, I can't plug a negative or 0 into the into the natural logarithm, right? Or any logarithm for that matter. So I should check whether these guys, when I plug them in for v's, make problems for me, right? Okay, so,
That's a positive one, so it should have a problem.
see, so, but remember I'm subtracting 4 from it. So if it's smaller than 4, I'm screwed. This one says if it's smaller than 3, I've got problems. This guy says not smaller than, but bigger than 5 causes problems. You guys see that? So the only v's that are okay are v's that are both bigger than 4 to fit in this piece. Also bigger than 3, right? But that's trivial. And then on this side, they need to be smaller than 5. So I'm looking for v's between 4 and 5.
4.5. So 3 plus or 2 is the only one.
Yeah, so 3 plus root 2 is between 4 and 5. 3 minus root 2 is,
It's like negative, or it's 1.6.
yeah, it's like 1.5 more or less. Right? Root 2 is about 1.5. So this guy didn't work, that guy does. What's up?
What if I calculated square root of 8 over there? So I don't have 2 square roots of 2 and all
so you-
that stuff. I have this number approximately.
Yeah. It depends on what you're doing. In this class, I value the hard equal sign much more than I value a number, right, or a convenient number. So that approximately equals to, in my mind, is not actually the right answer. Right, it's close, but it's not quite the right thing. Here I want to do exact work so we can decide our rounding later. You decided on some rounding in the process. Whether or not that was good for the application is unknown. Does that make sense?
How should I
We really should have 3 plus root 2. The approximately equals to, I think, is going to cost you half a point. Okay. Cool? Questions on this? Okay.